Welcome to part 2 of the Chapter 17 notes. We're going to look at similar triangles. So similar triangles need to be both the same shape, and how you can identify that is looking at the angles. The side lengths don't matter, it's the size of the angle. So as you can see in this example, these angles are the same, so we can identify these as similar triangles. Be careful that they may not be sitting in exactly the same positions. One might be flipped, rotated, etc. Also, with similar triangles, if they're giving you a triangle, they may give you a similar triangle like this. As you can see, we've got the same angle for this hypotenuse line. So if they're giving us, say, length of 10 there, and they're giving us the length of 10 there, for the large triangle, we've got a length of 20. So make sure you identify that. So don't just use 10 and 10. Calculating the scale factor. So the scale factor is kind of a multiplier, or how much bigger one shape is than the other. In this example here, the question is asking us to find the size of this X length. So there's two ways we can do this. We can use the scale factor K method, or we can do a cross multiply method. So using the scale factor K method would probably be the more common one, because I'd ask similar questions in examinations and SACs, etc. So by using the scale factor K method, I always like to go big over small to find the scale factor. So you pick the same side in both shapes. Big over small, or large over small, that equals 2. This here then is your K factor, so your K factor is 2. Then to find out what the unknown side is, check whether you're going from big to small or small to big. In this case, we're going from small to big. Just multiply it by the K factor. So 5 times 2 equals 10. If we were going to go from big to small, you'd then have to manipulate it, whether it's a divide by the K factor or times by 1 over K. Cross multiply method, you pick the same side. So once again, it doesn't matter if you go big to small or small to big. So for example, 4 over 8, then you have to do the same small to big as the same ratio. So 5 over x. Cross multiply in there, so we get the 4x, and then we get 40, and solve for x. So there's an example where with similar triangles you're using cross multiply or the scale factor K. I'm going to skip past this for the minute and look at using scale factor K in terms of area and volume. So we've just gone over how we can find the scale factor. I like saying going from large over small to work out that K factor. If we're using area, and a question might say calculate the unknown area, and you've been given two sides. Well, first off, work out your scale factor. So here's an example. If we've got a small area and a big area, that'd give you two sides to allow you to find your K factor. Then, because area, it's squared, we square our K factor. So your area, if you're going to find the large area, do your small area times by our K factor squared. And a couple of examples there of how to work backwards if we want to find the small area and they've given us the large area. Two examples, whatever works best for you. With volume, it's the same process. We need to find K factor, so we'll be given same sides, and you work out the K factor by going big over small or large over small to work out the K factor. Then, because volume's cubed, we cube our K factor. So just remember the units on area is squared, units on volume is cubed. Those numbers are what you either square or cube your K factor. Once again, whatever works best for you. If we're going from a large volume down to a small volume, how you manipulate your K value and your operation there, times or divide. With the scale factor, when we find our scale factor, for example, in this case it's 2, we can express that, if our K factor there is 2, we can express it in terms of a ratio 1 to 2. So if we kind of look at the ratio, it would be 1 to your K factor. That's how we would express it as a ratio. So in our example, we have our k-factor was 2. That means for every 1 unit in the small shape, there's 2 more units in this shape, or it's 2 times that. So if we had, for example, we had our k-factor equaled 300, then from A to B, if we're going small to big, our ratio would be 1 to 300. So that's how we can express our k-factor in terms of a ratio. Be very, very careful just to check that that's not asking for the ratio of, say, B to A. Just read the questions very, very carefully. Okay, going back to volume and surface areas. The volume of a shape, there is area of the face times height. So if we're working out, say, the volume of a cone, not a cone, a cylinder, sorry, work out the area of the face and then times it by the height. Or you are given multiple formulas to work out the volumes. So have a look through all the different volumes. And now approaching surface area. This question here, if we have a sphere, if we turn a sphere into a hemisphere, so there's our sphere, if we turn it into a hemisphere, be very careful, you don't need to subtract the bottom of the circles because it's like a bowl. You've got the surface area and it's open. That makes a full sphere. Other shapes though, if we're calculating surface area of an object and then we add something on top, say for example a square base pyramid, you need to make sure that you're subtracting the surface area of the top of the prism and the bottom of the square base pyramid, because those surface areas are inside the shape. Be very, very careful of knowing when to subtract areas off shapes for surface area. Example, if we had a hemisphere and we were to put that on top of a cylinder, we would have to only subtract one area, which is the circle on top of the cylinder. Because the hemisphere is open, we don't need to subtract a circle for surface area off the bottom of the hemisphere. So all the formulas are here for surface areas. If you don't have a formula, you then need to turn your shape into a net. And generally, it's going to be used in triangles, anything that's got triangles. So it might be a square base pyramid, would open up to a square and the 4 pyramids, or 4 triangles on the side. So go through, you should definitely have these formulas in your resource notes. Make them accessible, easy to read, easy to understand. I hope you have got something out of the Chapter 17 Part 2 notes, and thank you for watching.